There are two formulas that govern static friction, and each of them is just a little bit different, and we'll look at each formula in a couple of examples. One of them is for the maximum static friction force. Let's say, first of all, that a 10 kilogram block is on a ramp. And let's say that the block remains at rest. What would be the minimum coefficient of static friction for which this block can remain totally at rest? Now, we already know that if a block were on a frictionless ramp, that block would accelerate. I'm going to draw a free body diagram for this block, and we want to look at the force of friction that causes it not to accelerate. There's a weight for the block. We had said in the past that the weight can be broken down into its components. The weight in the x direction, the weight in the y direction. We had also said that there would be a normal force, which would oppose the weight in the y direction. And now, why is the block motionless? Well, there must be a friction force equal and opposite to Wx. But this time, we're going to call it F with a little s subscript, meaning static friction, as opposed to kinetic friction. Now, why is it static? Because the object is at rest. It's not moving. Now, since we're looking for the friction to be the most that it can possibly be in this situation, I'm going to use this top formula, which says Fs max, the maximum possible static friction, equals the mu sub s, which is the coefficient of static friction, times the normal force. Now, it's going to take a little work in this problem to determine what that normal force actually is. We do have a formula for it. The formula is the normal force will equal the weight times the cosine of the theta of the ramp. Okay, so let's go ahead and plug these things in. Okay, how big should the friction force be? Well, it should be as big as Wx. But what is Wx? That would be W sine theta ramp. Okay, so let's plug that in now. Okay, as we can see, the weight of the block itself won't even matter. And we can divide to get the sine of the theta over the cosine of the theta equals mu s. In other words, mu s is going to be the tangent of the theta of the ramp. And tan of 20 is 0.36. So as long as the coefficient of static friction between the surface and the block is as high as 0.36, then this block can remain at rest and it won't slip.